Lesson 8, Modeling with Series. You can use geometric and arithmetic series to model real-life situations, such as a salary increasing by the same percentage each year would form a geometric sequence, and the total amount paid over the sum of n years would follow a geometric series. Let's do an example. Bruce starts a company. In the first year, his profits are £20,000. He predicts it every year to increase by £5,000 until it reaches £100,000, where it will then stay at £100,000. Part A, let's find the total profit in the first 20 years. Part B, states a reason why this model may not be suitable. And Part C, Bruce's accountant says profits are likely to increase by 5% each year. Using this new model, calculate the profit for the first 20 years. For Part A, we first need to find the year that the total profit will reach 100,000. We know in year 1, the profit is 20,000. So we can say A equals 20,000. This is an arithmetic sequence, as it's going to increase by a set amount, 5,000 every time. So we know D equals 5,000. We know UN equals A plus N minus 1 D. And so UN in this case will be 100,000 equals 20,000 plus N minus 1 times 5,000, which is 20,000 plus 5,000 N minus 5,000. This combines to make 15,000. 100,000 minus 15,000 is 85,000 is equal to 5,000 N. And so N equals 17 years. The sum of the first 17 years is N over 2, so 17 over 2, times 2 times 20,000 plus N minus 1, 17 minus 1, times 5,000, which is 1,020,000. This is for the first 17 years, but then we need the last 3 years. So S20 is equal to 3 times 100,000 plus 1,020,000, which is 1,320,000 pounds in the first 20 years. For Part B, questions like this usually want you to give an answer in terms of the context of the question. So any answer that is suitable is fine, such as, it's unlikely that the profits will increase by the same amount each year. For Part C, we can see that it follows a geometric sequence because each profit next year is 5% more than it was the previous year. So we can say the first term A is 20,000, and the common ratio is 1.05, which is 1 plus 5%. So we know the sum of n is A times r to the n minus 1 over r minus 1. And so we want S20, which is 20,000, times 1.05 to the 20, minus 1, all over 1.05 minus 1, which is 661,319.08. So therefore, the total profit is £661,319.08. Let's do one more example. A piece of A4 paper is folded in half repeatedly. The thickness of the paper is 0.5 millimeters. Part A, find the new thickness after 4 folds. Part B, find the new thickness after 20 folds. And Part C, give a reason why the model may be unrealistic. For Part A, we can see that this will follow a geometric sequence as the thickness is doubling each time. So we can say that A equals 0.5 millimeters and the common ratio is 2. After 4 folds, it will be the 5th term. So U5 is equal to 0.5 times 2 to the 4, which is 8 millimeters. For Part B, we use the same method. U21 after 21 folds will be equal to 0.5 times 2 to the 20, which is 524,288 millimeters. For part C, again, for questions like this, where they ask a reason why a model may not be suitable, make sure your answer is in context of the question. So for example, you could say, it's impossible to fold that paper that many times, so the model is unrealistic. And that is it.